So I want to talk about a couple things before you get there. How do you check your answer if I give you this worksheet, right? If I give you this worksheet, how do you check answer? But let's draw something that's actually kind of interesting. So let's just say today, I'll give you an equation. So for example, like x squared minus 4x equal to 3, something like this, right? How do you use decimal to solve it, right? The key thing is you want to move, make sure, oh, sorry, this one's -3. So x squared minus 4x plus 3 is equal to 0. But how do you using decimal to help you solve it? The thing is, never, ever graph equal to 0. So I'm going to show you the difference between the two. What you're going to do is you only graph this part, and you look for x-intercept. You look for x-intercept. Does that make sense? You look for x-intercept. So if you graph it, and I'm showing you the difference, right? X squared, I think I say x squared minus 4x, right?
Yeah.
Okay, so you can click into this, and you're going to say, well, x is equal to 0, x is equal to 4. You don't have to know how to factor. The nice thing is you have decimals, you don't even know how to factor. If you know how to factor, great, but you don't have to know how to factor. You can actually find the evaluation very quickly. The problem is people says equal to 0. Now you're gonna see this two straight line like this, and you're gonna say, oh, I always prefer to just write down equal to 0, just type it exactly as. This is really bad because sometimes this point you're not able to click in. Right now it does. Right now it does. Okay, so I'm gonna show you what's the case that doesn't click in. That just says maybe x over x minus 1. I don't know if that work. This one is able to click in, or equal to 0. So equal to 0. See, do you see that? I cannot press that button. I cannot press that x-intercept. There's a bug in Desmos. If you set it equal to 0, you cannot click into it. What if the answer is 0.02? You won't be able to tell that's 0 or 0.02. Do you see what I'm trying to say? Try it. Try it right now on Desmo. Get your phone out. Try it. So never graph that equal to 0 part. Is very essential. Always just set equation equal to 0 and just graph that equation and look for the x-intercept.
Actually, y equals 0.
You can, but that's too much work. What this is much better work right here. Look, this is much better work. This you find out the 0, you can click into it. As opposed you say equal to 0, you're not able to click into it. So always just graph that things without equal sign. Move everything to the left side, graph that thing without equal sign, you look for x-intercept, that's all your solution. Does that make sense? Okay. Now I'm going to show you those questions here. How do I check this answer though? How do I check this question, whether my answer is correct or not? So what I'm going to do is I'm going to do what? Cosine of pi x minus 0.5, but I don't graph the equal sign. Does that make sense? So try it. Try it. Use your phone. I don't care. If you using the play Brawl Star, I'll throw it out the window, just like Bennett. Next time, I'll throw Bennett out the window. Right, Bennett? Huh? It was minus 0.5, right? Okay, so look at this. The answer is 0.333. It's 1 over third. Do you see that? The answer is 1.667. Is what? I think that's 5 over third. 7 over third. I think this is 14 over third. I think you're gonna have all the answer before 6.28. So you got all those answer. It's all listed for you. So if you want to check your math, if it's right, and I hear Brendan says, I just check Mathway. Please don't check Mathway, because Mathway doesn't teach you math. This teach you understand how to use decimals. If you use this consistently, SAT, a lot of things that you don't have to solve, you can just plug in, boom, done. You just need to know how to set up the equation. because on the test you cannot use Mathway. On the SAT you cannot use Mathway. But this is the best alternative source. I'm not just saying Mathway is bad. I'm just saying Mathway doesn't provide you additional value on the actual test. I'm trying to say it's like that. Yeah, but check your answer, use decimals. And that way you can check your answer. Yes.
Exact same thing. I didn't get the same points.
Okay, did you put a parenthesis pi x? Can I see what you have? Can I see your phone? See, that point you can click on it. But if you do equal sign, let's say do equal sign today, equal to 0.5, you see a bunch of lines, you cannot click into it anymore. Yeah, but you don't know what a value is. So that's actually bad. So remember, just by this alone, like this is a good SAT things that you guys need to think about. Even a lot of like SAT guru on TikTok actually did it wrong. They actually put an equal sign, and I look at it, I follow them. I'm like, that's laughable. They cannot click into it. They don't know there's a bug on decimal. It's not a bug. I agree with decimal. You're not supposed to be able to click into it, but it is a bug. So make sure you don't graph the equal sign. That's what I'm talking about. Another thing that you might have to do is like this. How do you know that you have to do the 2m pi things? So when to use 2m pi? When to use 2m pi or m pi? Now, 2m pi is going to be for sine and cosine. Is that okay? M pi is for tangent and cotangent. Is that okay? Because the period of sine and cosine is 2 pi. The period for tangent is pi. That's why we use m pi rather than 2m pi. Depends on what the situation is. Am I going too fast?
It's 2m pi sine.
No. Sine or cosine. So if you have sine of 3x equal to this, or sine of 5x equal to something, what is that? So you're going to use 2m pi rather than m pi. M pi is only for tangent and cotangent. So I'm going to show you a question. So for example, on that worksheet, there was a question like this. Tangent of 2x equal to negative root 3 over 3. When they use 2m pi, is this here is not a single x. It's 2x or 3x or 4x. And this is equal to a value. Why? Because sometimes you can have sine of 2x equal to cosine of x. That is not multiple angle. So this is 2x. Usually rule of thumb. Oh, do you guys know what rule of thumb come from? No. It's really bad, by the way. You should look at the rule of thumb. Like the origin of the rule of thumb. It's actually horrible. It's horrible.
Can I look it up?
You can. Huh? He's looking it up right now. Huh? Yeah. That's what rule of thumb means. It's pretty crazy, right? Yes. Yeah. So yeah, it's very messed up. I didn't know that until like I think when my history teacher told me. I was like, oh, that's interesting. I didn't even know that. I don't know why they call it rule of thumb. You thought just like this, but it's not. All right, so so this is a 2x. That means usually double amount of answer. 2x makes 4 answers. Why do they make 4 answers? Because they compress the graph. So whatever, just look at the sine of x, right, versus sine of 2x, right, versus like this. And I'll show you on the graph that why do you do that. So if you do sine of x and the sine of 2x, do you see that the x-intercept is gonna be more amount, right? Because it compress the graph, squeeze the graph to condense. So if you condense, guess what? You're gonna create more x-intercept. The problem is, how do you find rest of the x-intercept that's between 0 to 2 pi? So that's why we need 2m pi comes in, because the period is 2m pi. Now it's squeezed to become m pi because you divide it by 2. So that's why it's 2m pi divided by 2. It's squeezed in. And then you add each time. Armin, yes?
Is that why there were 6 solutions on the last one? Because it would be
Pi x. So pi is 3. So there should be 6 answer. Now, could be like, it depends. If it's 6.7, then you probably can only have 5 answers. So it's very like, because that's why I say that question is kind of interesting, because that's called a multiple angle trig equation. In this situation, it's called multiple angle trig equation. And that's why you're going to go with this. You say, okay, that just means when tangent equal to negative root 3 over 3, when tangent equal to negative root 3 over 3 happen where? 5 pi over 6 and what? 11 pi over 6? Are you sure? 11 pi over 6? Yeah. Plus, what do they plus here? Where's m pi, right? Now remember, it compresses because the period used to be m pi. Now you can divide it by 2. So it'll be 5 pi over 6 plus m pi over 2. Does that make sense? X equal to 11 pi. Oh, it's not 11 pi. 11 pi over 12. So 11 pi over 12 plus m pi over 2. Is that okay? So that means m pi over 2 divided by 2. So that means you're going to have more. So now you can go ahead and figure out what n equal to 0, n equal to 1, n equal to 2. The whole idea is to make sure you get 4 answers because you have 2x. So n equal to 0 is just x equal to 5 pi over 12 and x equal to 11 pi over 12. And this one's x equal to 5 pi over 12 plus pi over 2. Because this is n is 1, x equal to 11 pi over 12 plus 1 pi over 2. So if you need these common denominators, 6 over 6, that's going to be 11 pi over 12, which is same answer as the previous one. Do you see that? And this one is going to give you what? 6, so it'd be 17 pi over 12. Is that right? So we got one answer. The second answer repeated. Okay, so you had to go n equal to 2 now. X equal to, for tangent, you had to go a little bit more. So x equal to 5 pi over 12 plus pi 2 over 2, which is pi. So which is adding 12. So it'll be 17 pi over 12. And x equal to 11 pi over 12 plus 12 pi over 12, which is 23 pi over 12. Now you're going to say, do I go n equal to 3? No, you don't go n equal to 3 because n equal to 3, that means you're going to be over 2 pi. But you only want to find your answer between 0 to 2 pi. So you're going to solve for that. Yes?
You can also just count by 6 on top of and 0 to n1. Just another 6 from n1.
If you know the pattern, yes. Technically, just list down the rest of them. Yes.
How come we don't have the n pi over 2 to the actual answer?
Because we so this solution is called, there's a special name for this. There's a solution like this called particular solution. That means a particular solution between 0 to 2 pi. If you're adding m pi over 2, that's called a general solution. That means you find out rest of the x-intercept when n is equal to 1, 0, 2, 3, 4, 5, 6, 7, 8, 9, 10 to 1,000 to a million to infinite. So there's infinite amount of x-intercept after that. So that's called a general solution. This is called a particular solution.
Even because it's like tan still though. I thought tan had an infinite domain for the side.
Yeah, it does. So you have more x-intercept somewhere down the road. So I think this one's 10 of 2x, right? So 10 of, now we're gonna practice it. How do we do that? I think it's plus root 3 over 3. Is that right? Remember, we don't graph equal sign, right? Now click on the x-intercept. Now there are infinite amount. But if you plus 2m pi or plus m pi over 2, that's just the infinite amount representation. But I don't care about infinite number representation. I only care about 0 to 2 pi. Then I'm going to list all the answers between 0 to 2 pi. Does that help you solve the problem? So I think that's a misunderstanding for a lot of them. Yes, go ahead.
And then you would do the same thing for cosine or sine if it was like 2x except with the 2n pi?
Yes.
Okay.
So if today I ask you a question like this, sine of 3x equal to 1/2, how many solutions there are? 6. So you need 2m pi to find out all 6. However, sometimes you get this question, right? Sine of 2x equal to cosine of x. Now this one has nothing to do with multiple angle. Why this one has nothing to do with multiple angle? Because sine of 2x can change to double angle. So that's going to be 2 sine of x, cosine of x equal to cosine of x. Also, a lot of you guys create a bad habit. You say, how many of you guys think you can divide both sides by cosine of x? Raise your hand. You do. Thank you, Baylor or how to say it? Balin. Thank you, Balin. He was the one that brave enough says, hey, I don't know. And that's okay, because that way I can teach him. Don't be afraid, says, I don't know. I think a lot of you guys just say, hey, I don't want to be stupid. I don't want to be looking stupid. But it's nothing wrong if you ask question now. You want to make me better teacher. You want me to be better teacher. He's trying to be a better student. Somebody says, hey, I don't know. I'll be the first one to admit I don't know. It's always nice to be the first person who says, hey, I don't know. Because I'd rather you telling me than I just going to breeze by and says, I pretend you know. Or you pretend you know. But on the test, you end up don't know. And that's a bigger problem. So I appreciate him that just saying the answer. Now, don't divide it by cosine of x because you get rid of 2 answers. Imagine you have x squared equal to x, right? And I think you did this on your test as well. You divide by both sides by x is x equal to 1, and you write down one answer. But the truth is, the fundamental theorem says x squared equal to x. That means x squared equal to x. That means there's 2. That means according mathematician named Frederick Gauss, he's a father of algebra, and he says fundamental theorem of algebra says if that's second degree, there must mean 2 solutions. It can be complex, it can be real, but it has to have 2 solutions. So then, therefore, x squared minus x equal to 0, x times x minus 1 equal to 0, x equal to 0, x equal to 1. So that's why when you list down x equal to 1, I don't give you credit. I don't want to give you credit. It's not because you're wrong. It's because your answer is incomplete. Hopefully I answered that question. Yes.
And so that theorem applies to any like equation with an exponent in it?
No, it doesn't apply to trig because trig applied differently. Well, polynomial, algebraic foundation from polynomial for anything x to the whatever power, yes.
Okay.
So now 2 sine of x, cosine of x, since you don't divide it, so that's going to be cosine of x equal to 0. Take out cosine of x equal to 2 sine of x minus 1 equal to 0. Cosine of x equal to 0, x equal to pi over 2, and x equal to 3 pi over 2. See, you just killed this 2 answer if you divide by cosine. That's why you don't divide by cosine. You divide by cosine is bad. 2 sine of x minus 1 equal to 0. 2 sine of x equal to 1. Sine of x equal to 1/2. X equal to pi over 6. And 5 pi over 6. You could have killed those 2 answers. That's why you always say equation is equal to 0, factor out. The one with tangent and secant do not change for sine and cosine. Just stay with tangent. Factor out the tangent, and you solve the problem the same way. Now, here's the interesting thing, though. Imagine that you didn't follow what I said about the equal sign, how to do on decimals, right? So what we're going to do, we're going to do on decimal. Now, I'm going to tell you, this one's not multiple angle equation because this side is not a number. If this side is a number, then the multiple angle equation. Now, this is here, if I were to type in like this, and you guys should try it too. Sine of 2x, right? And just remember, we say cosine of x. We're gonna write down like this. It shows a straight line, right? Again, you cannot click on it, but if I do minus cosine of x and without equal sign, they actually show me solutions, right? It actually, you can click on all the solution. Very, very important. However, if I change the double angle identity, you'll find out they don't graph. If I change that double angle like this, do you see that doesn't graph? What is wrong with it? Why does this one doesn't graph and the other one graph?
Does it not recognize the double angle?
No,
You forgot to.
you're right.
Cosine.
Yeah.
What?
Did you add the x to the cosine?
With 2x.
Oh, okay, let's type in x here. But it's still not graphing though. It is multiplied, so what do you need? Parentheses. Now, if you see this is a parenthesis, this is a parenthesis, do you see that all of a sudden that they can recognize that now? They can plug in. So those are the bugs that they have on decimals, that if you don't pay attention, that's gonna be the one that costs you. Say, oh, well, why it doesn't come out? This is the reason why it doesn't come out. And just because I think they cannot recognize the sine x, cosine of x, so they probably think about is sine function, sine of no argument with x cosine of x. So the decimals cannot come out, and I think that's my logic. But yeah.
Like parentheses, sine x, cosine x, and parentheses.
What?
Like parentheses, sine x, cosine x, and then end parentheses. Like put them in the same bracket.
Let's try it. I don't know. Can't tell you what's wrong with it. You say parenthesis at n?
Yeah.
It doesn't work. So yeah, so those are the things that you have to pay attention to, and that'll be better. Okay, so yeah, does that make sense? Okay. Any other questions from homework? Did somebody post it on group chat? The other worksheet is better. I feel like the other worksheet is better. Yes.
You go over number 3 on the front, the 2 cosine squared of x minus sine x minus
2 what?
cosine squared of x minus sine of x minus 1 equals 0.
I love this question, by the way. You are going to see on the test. I'm glad you asked that. But the problem is this factorable? Not as a moment, right? What's wrong with it? They are not, one is cosine square, one is sine of x. They're not uniform. So let's change, what do we do? Change it to become uniform. Using this. Does that make sense? Then everything's in terms of sine x. Then you can factor this. And I think I'm gonna move everything to the right side just because I think I prefer leading coefficient to be positive. That's easier to factor. Is that okay? I prefer to move the other side. I can multiply everything by -1. I can do that, but I prefer to move everything on the right side because I can see that. And I don't like the first coefficient to be factored. And this is why I say box method is better. Nearly. Box method is better. Quadratic suck. She's ignoring me. So this one is here. And you can show up. You can say it's 2 sine of x, sine of x. And this is negative, so it'll be 2 sine x minus 1 times sine of x plus 1 equal to 0. Sin of x equal to 1/2, sin of x equal to -1, and there's a pi over 6, and there's 5 pi over 6, right? And this is -1, so this pi over 2, 3 pi over 2. So 1, 2, 3. If you graph it, you're going to find all those 3 solutions. Yes?
I'm sorry, I'm not following. Where did the 2 in front of the 2 did the 2 go that in front of the -2 sign?
Period bus passes.
Oh. Thank you.
You're welcome.
What did you say? Can somebody answer his question? I'm trying to take care of this. Thank you, Gabriel. Questions? Yes.
Number 11 on the PDF you just posted, would you do it the same way? Even if
I don't know what is it, but I'm gonna go find it. 11? Yeah, this is still multiple angled, so that means if it's x over 2, what many solution you think it's gonna be? But again, this is 0 to a pi though. So you had to count all the way to 0 to a pi. I don't think. I think it's if I think right, it's wait. Hold on a second. I don't know. I can't do math like that. I think it's 2. I'm not sure. Somebody graph it and let me know. Between 0 to a pi though.
So yeah, the test is going to be just more and more to this stuff.
Yeah, because the whole idea is actually I need to know your trig values and how your identity works. It's not a one sum and difference. That has no relevance. Adding fractions is not a big deal.
Right.
So, for example, question 4, right? I did it wrong here. I did it right over here. There's the answer of 2 pi here, but the 2 pi is not in the domain.